Amongst the terminologies we defined actually in chapter number 2, it was the SQL CLR, the stored procedures, and the stored procedures CLRs. All of them, they are a sort of predefined, let's say user-defined procedures that they have to be saved somewhere from within the project body to be utilized again and again whenever needed by just simply calling the name and calling the execution entry. The CLR, the Common Language Runtime, is a technology that persists whenever we talk about the TSQL as an enhancement to avoid inferences and to segregate functions amongst the engine parts. Some are related to the SQL Server, so it's a back end. Some are related to the front end, so we need an API or something like that. The CLR, they are the technology that they do actually their job from the back end side. They are the stored procedures, so SQL Server side. We'll define all the entities responsible for running a CLR, a SQL CLR, and we'll see actually some of the issues. Let's say we may say vulnerabilities or frauds that they can cause an issue when running a CLR or when calling a CLR. The index of this unit, actually, it is the content of this chapter fully. The five, I was saying that the entities they are responsible for running a CLR, actually, they are entities we are going to define one by one. They are five mainly. We talk about the stored procedure, the SP, because the stored procedures, they are from an API side. And CLI, it is a stored procedure also, but it is from SQL Server side, from the back end, how to reach it. So we'll be, in some cases, the scenarios, we'll see the scenarios where we need the stored procedures. We'll define, and this is one of the entities that helps the CLR to run or to be in action, to be seen in action. The triggers, she's coming now. Good. The triggers is another entity responsible for running the CLR. The triggers, they are a sort of let's say, cause to fire an event. They are sorts of, let's say, yes, they are causes. They are events to cause an action to happen or something like that. We define that and briefly in unit number 2, but we are going to see the details in this chapter number 2. Number 3, functions, or let's say predefined functions. We are going to use the responsible functions for helping the CLR to run. CLR at the end of the day, it's a stored procedure, but we are going to use predefined methods to construct whatever we need. Aggregates, because we are going to pass queries at the end of the day. So we'll need to use specific aggregates from within the queries bodies. And most important thing is that we're going to define our specific types to help our program to be centralized or our solution to be centralized somehow. So stored procedures, triggers, functions, aggregates, and utilities, they are the entities behind running, or let's say bringing a CLR to life. You have to memorize those things. We are going to see and define them one by one, but even though you have to memorize them. Security, actually, scope, we are going to define more than one security perspective here. We are going to tackle one new thing, which is the context of the secure coding, and we see that one by one, step by step. Let's get started. The security actually concern, and the major concern in this chapter number 3, is the SQL injection. Remember that we are tackling the SQL Server as a Microsoft technology, but it's not the unique. The SQL injection described in this chapter itself, which is defined by the Microsoft, it is tackling the Oracle as one of the frameworks, as one of the technologies that they can actually be missing effectively implementing, let's say deploying queries, or let's say receiving queries, or it's a question of attack against the SQL injection, no more, no less. So this issue, it is a persistent issue, whatever it's SQL Server, your DBMS, or any other professional tool. We are seeing three queries here in front of us. The three, they are doing the same task, but differently written. We are seeing three queries, 1, 2, and 3. The three, they are doing the same task, yet differently written. Let's describe them to see what they are doing, and then after we'll talk about the way, the syntactical view. First of all, we are extracting a number of records from an entity. Simply select count of from. Then the second, we are doing the same thing but different. We are using a predefined method, which is the num rows from an entity, and you are specifying that the entity has a name, which is the employees. So differently written completely. We are using predefined functions here. I come back to the entities, building a CLR, the functions. They use defined functions. So here, select num rows from user tables, and the user tables, it's in the work clause. It has to be employees. What does this query do? Fully, it just reads the number of rows, number of records, and the entity employees. So it's the same like this one. This is a very basic query. Select count. It uses the aggregate. It uses the aggregate count from the entity employees. The third, it is almost similar to the first one, yet one unique distinction is the double quotation. The double quotation. So select count what from the entity given here. Simply. So here we come to a conclusion is that the three, they are doing the same. Actually, they are described in our book. So if you refer to the book, you'll find them all. Good. So the three, they are actually extracting a value from an entity. What's the problem here? The problem is that we are not making a decoy here. We are not making one very long like this one to come to our view. We are not making it very simple and very short to make you understand. No, we are tackling the security view here. The three of them, they are doing the same output if everything is very fine. If we are in an isolated system, so we will choose the shortest one. If we are in an isolated system or environment, we would be choosing this one. Why? Because this one is very simple and neat. Select what you want from the entity. Full stop. Nothing to worry about. Yet, this still would persist even if it's in a non-isolated environment. Why? Because let's tackle. We all, through the digital course, actually, we recognize very well, and the cybersecurity also course, we recognize very well the SQL injection, how it runs. So this is not new to us and to you as a student of the database security. You are at least aware, and I believe that you had the assignment number 1, which is in which I asked you to manifest the SQL injection in the FoverBay.com. So you know what the SQL injection, how it looks like. At least you have a minimum recognition of that. This one would persist still even in a non-isolated system. Why? Because if you remember very well the 1 equal to 1 attack, it uses a simple 1 equal to 1, but it has to be preceded at the beginning with a single quotation to terminate what the submission has to send and validates whether 1 equal to 1. So everything that it has to be actually passed, it has to be actually received and treated in between quotation. It is vulnerable to an attack similar to the 1 equal to 1, means here in conclusion, this query here, this structure here, this syntax here, and this syntax here, both of them, they are vulnerable to the 1 equal to 1 attack. I'm not explaining the 1 equal to 1 attack. I'm going to show it to you now. I'm going to just give you a small recap. Yet, here, those two, they are vulnerable to such attack. We come back to this first one. We said that it is very simple. And if we are in an isolated system, we would choose this one because it's very neat. It is very exposed, but still, when we compare this same query to those two queries against the 1 equal to 1 attack, this becomes the most secure. This one becomes the most secure. Let me just give you a small recap, just a small reminder about what this 1 equal to 1 attack. Actually, we have a username field and a password field via which, or any input field, we have an entry point via which we are going to pass a data that would be actually passed to a database upon a query. Saying that we are going to pass this query, for example, which is we are going to count the number of employees from this table employees, number of records. Good. So if the user, instead of typing, for example, instead of typing the name of the table, which is not the case, the table never to be written, but I'm gonna just remind you of the syntax. I'm gonna type what it is. So simply means the query will read this input, single quotation or 1 equal to 1. I'll start from the end here. 1 equal to 1 is usually, it's a test of equality here. It's not an affectation. It's usually true. So whatever the case is, it will remain usually true. Since we are terminating what it came before, if we are in this query only, this attack would be actually successful. Why? Because this is a single quotation. If the system is using this double quotation, this won't succeed, it will fail. Why? Because a single quotation will not close a double quotation. I have to put here what? A double quotation. But since I'm not able to read, they are actually a background, those are a server side, those are all of them. They are a server side context. They are things that actually be available in the server side and never to be brought to the client side. They will never be brought to the client side. So whether it is a single quotation or a double quotation, so they are not going to be seen by the attacker. But guessing that the attacker, because he's going to test the first attack, the second attack, the third attack, so he will try all the trials. He will do all the trials. He will use the single quotation, the double quotation, and all. But he will not do like this. He will not keep it empty and the middle right or 1 equal to 1. Because the system will read the space here and will not read it. He will not accept it. The space will not be accepted. So there have to be something here to relate, because before the or, we cannot find from. So before, we cannot find the from. So this one will not be vulnerable. This query here, it's not vulnerable to the 1 equal to 1 attack. Before I continue explaining, any questions, please?
Yeah.
I hope it's clear. I hope it's clear. So in conclusion here, this first one, which is the very simple, the very clear to understand, it is also the most secure against the SQL injection. And especially and specifically because we are going to see, we saw for the ones that they finished the cybersecurity course, they saw actually groups of the SQL injection categories. All of them, they are considered to be tackled in order to, they actually, all the queries, they have to be actually secured against the SQL injection types, whether they are 1 to equal to 1, tautology, or whatever. Let me turn everything like it was. So here in conclusion, we come to a conclusion is that the way how we build our queries, it's a question of security. So to consider the threat first, then after you construct your syntax. Yes, we will receive, we will reach the result. This is for sure. We will reach the result. This is for sure. Yes, this is the result. Yes, but which one to choose? So you have to tackle the issue first. You have to know what issues you are securing your system from. Based on that, you choose which best syntax for you. And this is a way of secure coding. This is a way of secure coding. Secure coding. Okay. The CLI itself, actually, it is for security reasons. It is by default disabled and disabled from where? From the environment that would be actually integrated in, which is the SQL Server environment, the background environment. And by default, it is by default actually off, and it has to be enabled manually by just calling the respective methodologies, the predefined functions, the enabled CLI. You have to give it a value 1. Once you state this one to be 0, so you are disabling the CLI. You state it 1, so you are enabling the CLI, and so on. So the CLI call from within a SQL Server environment is by default off, and it has to be enabled for security reasons. Why? Because the CLI actually it gives an entry point from the external environment to the internal environment. The internal environment, which one? Is the SQL Server itself. The CLI it is to be run from the SQL Server side, from the DBMS, from the engine itself. So if it calls an external resource, that is an entry point. That is actually a point that has to be controlled. So by default, it is off unless a user enables it. So it has to be enabled manually. Why? To avoid the default entries. There is no default entry to the system unless you manually specify that to need a specific entry from a specific user-defined function or user-defined procedure, or you are going to call something specifically predefined. Is it clear?
Yes, Mr.
Great. If you have any questions, you can interrupt me. That's great. That's great. Actually, at every step that the CLI is either enabled or disabled, there have to be actually reconfiguration to the environment to reconsider all the done, the priorly done commands, which are here mainly we're talking about enabling or disabling the CLI. So the process of the either enable or disable the CLI is usually accompanied with a reconfiguration of the environment to consider the configuration here, or this reconfigure command here is to consider what you've done here, what you as a user you've done in this step, whether the 1 or the 0, which is the enabling or the disabling. Great. When we consider actually the CLIs, and we said that by default they are the state is disabled, they are not enabled by default, they have to be manually done, and we said this is due to that they can actually acquire external resources to be run locally inside the internal environment, which is the SQL Server side. The assemblies is one of the examples that the CLRs can core or can integrate or can actually use to accomplish its task or its functionality. What are assemblies now? A CLI is a procedure that can be defined manually, can be defined by a user, so it can be actually nominated as a user-defined procedure to be run at the runtime, yes, but it is in a server side. To accomplish it, we need to have a trigger from outside external. We need to have a call to it from an external environment. We have to have a partner to it, an external environment to accomplish it's a task. If it is completely isolated inside the DBMS, so it's useless in an external when we try to relate it to an external project. It has to be with a relationship with an external, let's say, member. External to what? External to the database management system, the SQL server. Something like the stored procedures, simply. Stored procedures, they are procedures saved in the API, the SSMS or the SSDT or the Visual Studio. The APIs we define, unit number 1, chapter number 1. So whether it is a simple stored procedure that have a simple call or a complex one that has actually the integration of external resources like the assemblies, they all represent an external partnership with the CLRs. Let's define the assemblies themselves. The assemblies, they are actually .NET functionalities. They are .NET functionalities. Immediately you have to conclude, since they are .NET, means they are Microsoft-based technology. And they are related to the operating system. They are related to the external environment, not to the project. Not project, let's say, parties, whether it is the DBMS back end or the APIs front end. So for example, I give you the example. We are going to search the directories of the operating system, the documents, the pictures, the videos, the C drive, the D drive. We're going to search for specific files and specific resources. So whether we use a predefined search function, ready, we just use like it is, or we build a new one, which is best? Actually, best a matter of time and a matter of space of use, actually, memory space, to use the pre-available search function, which can be actually be provided by the Microsoft itself, the Microsoft OS operating system. So we can have an external library that have an external function to be used from within the project, the, let's say, the database based project, which is the in our question here, CLR stored procedure, or we can call it CLR SP. We define that in unit number 2, chapter number 2. So assemblies like the search functions or any other functions that they actually relate to the environment, not to the project. The environment, we talk mainly about the operating system, not only. Is either to implement them from scratch. At every time we need a new one, we implement it from scratch, or we use the available functions from the external world. We just give them the liability to be trusted and to be used from within the project itself. Those are assemblies. Assemblies. One first conclusion, and one very important conclusion, and one very stressful point is that since we talk about the .NET assemblies, they are related to the Microsoft only. This technology cannot be found externally from the Windows-based environments. It is related to the here, as per our book, to the SQL Server and SQL Server 2012 and above, means 14, 16, 19, all of them, they are actually enhancing this feature. Which feature? The SQL CLR stored procedures. Those assemblies, which are actually external resources to be utilized from within the CLR store procedure, let's say, I'm going to say CLRSP, they are either functions or types. Functions, I given you the example of the search. Yeah, we are going to search directories inside the operating system. So we're going to browse the C drive or the D drive or the flash disks or whatever, any storage device, the storage drive. So either we implement or we use the ready-made. The types we defined in the early age unit number 2, the generation of the user defined types or the table valued parameters. It's chapter number 1. All of them, they are sorts of types via which we can declare standardized types we can use again and again from within the project. So assemblies can be utilized to define global types, global variables, variable globally defined. From another view, assemblies also they can be utilized to define architectures of elements inside, let's say the outputs, the architecture of an output. When we state actually we are going to display a table or a grid that holds specific fields, columns, records, we can do that. Can be utilized for that. An assembly can define a view. We define what is a view. An assembly can define a stored procedure. An assembly can define a trigger, which is a cause to launch an action. An assembly can define a user-defined function. User-defined function. Whatever the function you want. As we said earlier, we can search. Yes, we can make display only. We can make insert. So all of them, they're functions. Assemblies. Any example, any questions, please?
No, mister.
Okay, I believe it's clear. That's good. Before I explain this example here, before I give you any hint of what is this example in front of us, I want to bring your attention to is that when we said that the assembly is a sort of a library that holds functions that we can utilize from an external environment or internal environment, if we talk about a user-defined function, so it is an internal environment here, functions. So it is user-defined, so it is an internal, internally to the system, to the project in question, user-defined function. You will not find it in another computer or in another environment, no. So, and when you said that we're going to search, let's say a storage device or a storage drive, so it is external to the project. Both things, they have to be actually supported by assemblies. Let's have a look to this. I'm not explaining still. I'm going to explain it one by one. Don't worry. But here, look at what I'm highlighting now. Look at what I'm highlighting right now. It is very regular path to a file, to a resource from within a Microsoft operating system. We are having the C drive at the beginning, and at the end we are having a DLL file. So this is a path to a resource. DLL they are data linked libraries. They are Microsoft based resources. And as per the name here, SQL CLR demo, they are actually, this is actually a sort of an assembly. This is actually a library. This is an assembly that holds something to do. It's a function to do, whatever it's the function here in our context. But we are linking, not we are linking, we are creating an assembly, and this assembly is pointing to this resource here. Right after immediately, I will not talk a lot, right after immediately, we created an assembly. Create assembly, we given it a name, and we pointed it here to this resource. Great. Later on here, actually, we are just going to link the external assembly. Create here is the server side. This command here is a server side. All of it from this is just one command. In green, all of it, it's one command. It's server side. Pointed to what? To this resource. Where it is available, here it is. This is the path. This is actually a resource in the Windows environment. So now after creating this assembly, we pass to the use of this assembly. And we created assembly. What to do? Just we link it? No. The assembly will not run by itself. We have to utilize it somewhere inside the project. Now this is a server side. Now, as per the syntax here, this is a C# block of code that is calling our procedure somewhere to be utilized. It is going to use the procedure somewhere to be utilized. So what this actually block do at the end of the day, it is around this query here. So select, it's just a simple output. Okay, simply yes, here it is. Okay, because I wanted to see this block here before I explain this part here. Actually, the simple block here is actually calling the SQL library that holds all the capabilities to pass all the functions to the server, which is the SQL server. This is a C#. It's not something understood by the SQL server. This is not something we can understand. This is to be written in the Visual Studio, something like that. This is to be written in the, for example, the SSDT, maybe, yes, and stored as a stored procedure. We can, as a stored procedure. Yes, we can, but not in the SQL server. It will not be understood in the SQL server. The SQL server only understands this block. See, select star from the entity we need. Here, this person, in this example, person. Select star from person. All the other, the SQL server does not understand. So what should we do? We have to generate it as a stored procedure, and the stored procedure will be available in the front end, in the API, whether it is the SSMS or the SSDT or the Visual Studio, whatever, and then we have to link the assembly and the stored procedure to be run all together, no more no less. So the stored procedure, which is this one, contact quick, here it is, the same one. This is the method. We are going to link to be run as this assembly here. So the procedure we are creating, sorry, the syntax, we are creating a procedure here again in the server side. We are generating a new procedure that has this name, which is the name of the method inside the block of the stored procedure. And this stored procedure would be executed as an external resource, which is the name of the assembly, And through that name of assembly, we are going to reach whatever we want, actually, which is at the end of the day, this method through this class. As prox.spContactsQuick. Then we call execution, or simply just the name. This is the name. Simply, either we use the keyword exec space the name, or simply this name. This is where in the query builder is in the SQL Server environment. It's from the it's in the server side environment. Any questions, please?
No, doctor, thank you.
Okay, if you hear your name, please say yes.